Hi, I'm Patrick Reagan. This video, TCP/IP Part 8 Complex Subnetting, continues the last video where we discussed simple subnetting, in which the subnets were broken along octet boundaries. If you have not watched the TCP/IP Part 7 Simple Subnetting, it is highly recommended that you watch that video first before jumping into this video. This video covers more complex subnetting where the subnets are not broken down based on octets. Instead, an octet is broken up where some of the bits are network bits and the rest are host bits. Similar to the last video, this is an excellent video to pause as needed to look closer on what is on the screen and to perform your own binary conversions. The last video, we looked at subnetting that follow the octet boundaries. When the subnetting follows the octet boundaries, it's easy to see and divide the subnets and host address. Complex subnetting does not follow the octet boundaries. Let's look at our first example. Let's say you have a company with multiple sites. Your company is assigned the following network address, 10.200.0.0, with a subnet mask of 255.255.0.0. This is a Class A address because 10 falls between 0 and 127. Therefore, by default, it is assigned a subnet mask of 255.0.0.0 or CIDR notation /8. But you're already assigned a non-default subnet mask of 255.255.0.0 or /16 as shown on the screen. As you recall, the subnet mask specifies which bits are the network bits and which bits are the host bits. So every host that you assign to your corporate network just begins with the binary address of 0000.1010.100.10000 or 10.200 since it follows the octet boundaries. The last 16 bits are for me to divide up and assign as I see fit. I'm going to use the next 6 bits to specify the site and the last 10 bits to specify hosts within the site. Since part of the third octet is a network address that specifies the subnet mask has to be modified to specify that those bits are network bits as shown on the screen. The 22, 16 plus 6 bits are masked indicating the network bits and 10 bits are not masked indicating host bits. Converting the third octet subnet mask of 11111100, you have 252. Therefore, the subnet mask is changed from 255.255.0.0 to 255.255.252.0 or CIDR notation /22. Now let's look at the branch offices and the associated bits as shown on the screen for the 6 branches. Remember, binary counting starts at 0. Every hosted site number 0 will begin with as shown on the screen. Because the first 16 bits are dictated by the corporation and the next 6 bits are dictated by the site or subnet, the subnet mask is not as obvious as it was last time because it is a subdivided octet. The first few hosts in the first site will be numbered in binary as shown on the screen. The full address of the first host in binary is also shown on the screen, or 10.200.0.1 with a subnet mask of 255.255.252.0. Remember, you cannot have all host bits set to 0 since that represents the network address. Therefore, you have to take the address after that, which is all zeros except for the last digit is a 1. The full address of the second host is also shown on the screen with an address of 10.200.0.2 with a subnet mask of 255.255.252.0. To calculate the highest address in the subnet, you would lock in the network address bits and set the host bits to all 1s except the last 0. Remember, you cannot have all host bits set to 1 since that represents the broadcast address. Therefore, you have to take the address before that. In this case, the binary equivalent is shown on the screen, which is 10.200.3.254. To calculate the network address, you would lock in the network address bits and set the host bits to all zeros as shown on the screen. Therefore, the network address for site number 0 is 10.200.0.0. To calculate the broadcast address for the network, you'd lock in the network address bits and set the host bits to all ones as shown on the screen. Therefore, the broadcast address for the first site number 0 is 10.200.3.255. If I go to the second site number 1, where the subnet is 2 equals 000001, every host at that site would begin with what is shown on the screen. The first few hosts at site number 1 are also shown on the screen with the subnet mask of 255.255.252.0. Remember, you cannot have all host bits set to 0 since that represents the network address. Therefore, you have to take the address after that, which is all zeros except for the last digit is a 1. To calculate the highest address in the subnet, you would lock in the network address bits and set the host bits to all ones except for the last 0. Remember, you cannot have all host bits set to 1 since that represents the broadcast address. Therefore, you'd have to take the address before that, which is all ones except for the last digit is a 0. In this case, it would be what is shown on the screen. Therefore, the highest usable address for the first site or subnet is 10.200.7.254. To calculate the network address, you lock in the network address bits and set the host bits to all zeros as shown on the screen. Therefore, the network address for the second site number 1 is 10.200.4.0. To calculate the broadcast address for the network, you would lock in the network address bits and set the host bits to all ones as shown on the screen. Therefore, the broadcast address for the second site number 1 is 10.200.7.255. And here is a summary of the site number 2, the third site. If I start to put this into a table showing my subnets broken down, you can start seeing a pattern where the third octet is jumping by 4. If I decide to add a 7th site in the future, I can figure it out pretty quickly. To calculate the number of subnets, you'd use the following formula. Number of subnets equals 2 to the subnet bits power. To calculate the number of hosts per subnets, we'd use the following formula. Number of hosts per subnets equals 2 to the host bits minus 2. The minus 2 is because all zeros represent the network address for the subnet, and all ones represent the broadcast address for the subnet. So in our example, we can have up to number of subnets or sites is equal to the subnet bits, which is equal to the 6th power, which is equal to 64. And each subnet or site can have up to number of hosts per subnet or sites, 2 to the host bits power minus 2, which is 2 to the 10th power minus 2, which is equal to 1022. Let's look at another example. Let's say in the building you have a data center with 192.168.3.0 with the default subnet mask of 255.255.255.0. This is a Class C address because 192 falls between 192 and 223. Therefore, by default, it's assigned a subnet mask of 255.255.255.0 or /24. You need a minimum of 5 subnets and you want to maximize the number of hosts for each subnet. The binary equivalents of the current network address and the subnet mask are shown on the screen. I need a minimum of 5 subnets. Therefore, you need to do some quick calculations to figure out how many network bits I will need to cover 5 subnets. Number of subnets equals 2 to the first power gives me 2 subnets. And the number of subnets equals 2 to the second power gives me 4 subnets. The number of subnets 2 to the third power gives me 8 subnets. So if I use 3 subnet bits, I can have up to 8 subnets. So out of the last octet, I'm using 3 subnet bits, which leaves me 8 minus 3 equals 5 host bits. Number of hosts equals 2 to the 5th power minus 2 equals 30. So for each of the 8 subnets, each subnet can have up to 30 hosts. Since I have 3 subnet bits and 5 host bits, the new subnet mask for the data center in binary is shown on the screen, which is equal to 255.255.255.224 or CIDR notation of /27. Let's say that I have 5 subnets as shown on the screen. Of course, we start our counting at 0. Every host at the first subnet, or site number 0, will begin with what is shown on the screen. The full address of the first host is shown on the screen in binary, which is equal to 192.168.3.1 with the subnet mask of 255.255.224.0 or CIDR notation of /27. To calculate the highest address in the subnet, you would lock in the network address bits and set the host bits to all ones except for the last 0. It cannot be all ones because it's reserved for the broadcast address. In this case, it will be what is shown on the screen. The highest usable address for the first site or subnet is 192.168.3.30. To calculate the network address, you lock in the network address bits and set the host bits to all zeros as shown on the screen. Therefore, the network address for the main site is 192.168.3.0. To calculate the broadcast address for the network, you lock in the network address bits and set the host bits to all ones as shown on the screen. Therefore, the broadcast address for the main site is 192.168.3.31. If I go to the 4th subnet, site number 3, where the subnet is 4 equals 011, every host at the site would begin with the address shown on the screen. The first few hosts on the 4th subnet is shown on the screen, and the last octet starting with 97 with the subnet mask of 255.255.255.224. To calculate the highest address in the 4th subnet, you lock in the network address bits and set the host bits to all ones except for the last 0. It cannot be all ones because it's reserved for the broadcast address. In this case, it would be what is shown on the screen, or 192.168.3.126, with the subnet mask of 255.255.255.224. To calculate the network address for the subnet, you would lock in the network address bits and set the host bits to all zeros as shown on the screen, which gives you a 192.168.3.96 address. To calculate the broadcast address for the network, you would lock in the network address bits and set the host bits to all ones as shown on the screen, and will give you the address of 192.168.3.127. If I start to put this into a table showing my subnets broken down, you can start seeing a pattern where the last octet is jumping by 32. Let's shift gears a little and look at examples on how to determine how to split out the subnet. Let's say that you have a 16-bit network address and you have 16 host bits to play with. What would the subnet mask be if you need to have up to 24 hosts per site and you want to maximize the number of sites? To calculate the number of hosts, we'd use the following formula. Number of hosts equals 2 to the subnet bits power minus 2. Therefore, we will work on calculations until we get at a 24 or greater. You would have 5 unmasked bits, which allows you to have up to 30 hosts per site. That leaves you 32 minus 16 minus 5 equals 11 subnet bits left, which allows you to have number of subnets or sites, 2 to the subnet bits equals 2 to the 11th equals 2048. The subnet mask is shown on the screen in binary, which is 255.255.224.0 or CIDR notation /27. Let's look at another example. Let's say that you have a 16-bit network address and you have 16 host bits to play with. What would the subnet mask be if you need to support up to 1,000 sites and you want to maximize the number of hosts? To calculate the number of sites, we'd use the following formula. Number of subnets or sites equals 2 to the subnet bits power. Therefore, you need to do some quick calculations. With 10 subnet bits, this will give us 1,024 subnets. To calculate the number of hosts per subnet, you use the following formula. Number of hosts equals 2 to the host bits power minus 2, which is 2 to the 6th power minus 2, which gives us 62 hosts. So if we started with 16 network bits and we added another 10 subnet bits, we have 26 network bits total, or CIDR notation /26. The binary equivalent is shown on the screen, which is equal to 255.255.255.192. As I've mentioned in previous videos, when planning your TCP/IP network, make sure that you plan for growth where you might add additional subnets or hosts in the future. Question. If you have a Class B network with a subnet mask of 255.255.240.0, how many subnets can you have? Answer, 16. For the subnet mask of 255.255.240.0, the binary equivalent is shown on the screen. This gives you 4 network bits. 2 to the 4th power gives you 16 subnets. Question. You have a Class B network with a subnet mask of 255.255.248.0. How many hosts can you have? Answer, 2046. For the subnet mask of 255.255.248.0, with the binary equivalent shown on the screen, that gives you 11 host bits. 2 to the 11th power minus 2 equals 2046 hosts. Question. You have a new office that you need to accommodate up to 412 network hosts on the same subnet. What is the smallest subnet you can use? Answer, 254. By doing some calculations until you get a number of hosts greater than 412, so it takes 9 host bits, which gives you up to 510 hosts. Rest of 32 bits, this network is 23 bits, CIDR notation /23, which is the binary equivalent shown on the screen, which translates to 255.255.254.0. Question. You need to have a network with 5 VLANs with the same subnet as shown on the screen. What is the smallest subnet that you can use? While each group of users will be within their own VLAN, it is stated at the same subnet, and there's a total of 295 users or hosts. During our calculations, the number of hosts until we get to the number that is 295 or larger, it gives us 9 host bits, which leaves us with 23 network bits, or CIDR notation /23. Question. You have a subnet with 55 hosts. What CIDR notation would you use with the least amount of unused addresses? Answer, /26. During our calculations, it would take 6 host bits that will give us up to 62 hosts per subnet. 32 bits minus 6 host bits equals 26 network bits, or CIDR notation /26. For more information, visit these sites. In summary, the subnet mask can be changed to take a large network and break it into several smaller networks called subnets. To calculate the number of subnets, you would use the following formula: number of subnet equals 2 to the subnet bits power. To calculate the number of hosts per subnet, we use the following formula: number of hosts per subnet equals 2 to the host bits power minus 2. Thank you for watching this video. The next video will be TCP/IP Part 9, breaking down an IPv4 address. If you have not already, subscribe to the Pat Has Your Back channel. Thank you.